Now let's get to work on a simple example problem using solution stoichiometry. Okay, so this one says find the concentration in moles per liter of the bromide ions in 15 milligrams of magnesium bromide in 175 milliliters of solution. Okay, so what happens here is magnesium bromide, MgBr2, which is typically a solid, goes into water, and what happens? It breaks into magnesium ion, which is aqueous, and then it also breaks into 2 bromine ions, okay, in aqueous solution. So this, now that we have a chemical equation, this can basically be thought of as a solutions stoichiometry type of question. So here are, I'm going to go through with you now a few steps which you can use kind of generally with any type of solution stoichiometry question, or any type of stoichiometry question really in general. So here we go. First of all, convert material quantities from the given substance into moles. Okay, so in this question we're told we have 15 grams of magnesium bromide, and that's the given substance in this case. We're told we have 15 grams of this, and then how much of the bromide ions, or what's the concentration of the bromide ions. Okay, so first of all we're going to convert to moles. So in this case moles is going to be N is equal to the mass divided by the molar mass. In other words, this is going to be 15 grams divided by the molar mass of magnesium bromide. To find the molar mass of magnesium bromide, we're just going to go 24.1 for the magnesium, plus 2 times for the bromine, 79.90, and this is all grams per mole. Okay, which should work out, if you plug that into your calculator, to be 0.0815 moles. Okay, pretty simple. We've been doing a lot of questions like that so far. Now that we're into solution stoichiometry, also be prepared to try to find the number of moles using the equation N is equal to concentration times volume. Earlier in the course we also learned that we can use the equation N is equal to number of entities, or number of molecules, number of compound units, number of atoms divided by Avogadro's number, which of course is 6.02 times 10 to the 23. Okay, so that would be step 1, converting material quantities from substances into moles. So now we know we have 0.0815 moles of magnesium bromide. On to step 2. Use stoichiometric ratios to determine the number of moles of the required substance. Okay, so the required substance in this case, we go up here, is the number of bromide ions. Okay, so we have 0.0815 moles, so the number of moles of bromine ions is going to be our number of moles of magnesium bromide times using the stoichiometric ratio. So that's going to be 2 over 1. Okay, and that works out to be 0.163 moles. Okay, so in this question we know that we've yielded 0.163 moles of bromine ions. Moving forward, step 3, we convert the number of moles of the required substance into the desired quantity using desired units. So let's see what our question says here. We want to know the concentration in moles per liter of the bromide ions from 15 grams of magnesium bromide in 175 milliliters of solution. Okay, so we're going for concentration, and we know that concentration is equal to number of moles over volume. We just found the number of moles of bromine, so we're going to have 0.163 0.163 moles divided by our volume, and the question told us that we have 175 milliliters of the solution. So we'll take 175 milliliters down here. Don't forget to convert milliliters into liters. 1 liter over 1,000 milliliters. Okay, and when we divide 0.163 by 0.175 liters, we find that the concentration of bromide ion is 0.931 moles per liter. Okay, so that was a very simple example of a solution stoichiometry question. We're going to get a little more complicated on from here. Here's our next example of a solution stoichiometry question. In this one, we're finding the concentration of a solution, a reactant solution, given the mass of a precipitate product, okay? So in this case, we're actually dealing with a single displacement reaction, which gives us a precipitate product. Okay, here comes the question. A student carefully measured 100 milliliters, going to underline that for future use, of silver nitrate solution, AgNO3, of unknown concentration. The student poured the solution into a beaker, added a coil of copper, and left the mixture for several days. When the reaction was complete, was a single displacement reaction, the student carefully scraped the silver from the copper wire and filtered the solution to obtain all the silver. The dry precipitate had a mass of 1.65 grams, important information there. What was the molar concentration of the silver nitrate solution? So let's go through our three-step process to solve this one. Actually, before we do that, I guess we better write out our chemical formula. So we're going to have silver nitrate added to solid copper, and it will produce copper nitrate, copper 2 nitrate, plus solid silver. And it's the solid silver that we scrape off at the end. That's the product that we have the mass of, and we're trying to find the concentration of the silver nitrate, which we have 100 milliliters of. Okay, so step one, as you may recall, is converting the given amount into moles. So we have 1.65 grams of silver. So to find the number of moles, we're going to take a mass divided by the molar mass. This is for silver. So we've got 1.65 grams divided by the molar mass of silver. So that should give us 0.0153 moles. Okay, step one is complete. Moving on to step two. This is the molar ratio step. So the number of moles of our desired material, this is going to be silver nitrate, will be our 0.0153 moles of silver times 2 over 2 is our molar ratio here. That's 2 moles of silver nitrate divided by the 2 moles of silver. Okay, so that works out to the same thing, 0.0153 moles of silver nitrate. That's step two. Moving on to step three is finding the concentration. Okay, we have number of moles, we have the volume. They said it was 100 milliliters of silver nitrate. So the concentration we can find by taking number of moles and dividing by the volume. So here we have 0.0153 moles of our silver nitrate divided by 100 milliliters. Of course, we need to convert milliliters to liters, so 1 liter divided by 1,000 milliliters all works out to be 0.153 moles per liter, and that's our final answer. Okay, so step 1, 2, and 3. Step 1, convert to moles. That's how many moles of silver we had. Step 2, use molar ratios. It's a 1-to-1 ratio, silver nitrate to silver. So we multiply that by 1. We've got our number of moles of silver nitrate. Step 3, convert that into whatever it is you're looking for. In this case, we're looking for concentration. N over V gives us our 0.153 moles per liter.